Welcome back. This is the last of the mechanics in this casual game mechanics series, but after this we're going to be doing systems and object pooling, just so we can build on top of that. So today we're doing a kind of one of the easiest puzzle games that I could think of. There's a lot like Tetris, your match threes, all that kind of thing, but I wanted to do, let me just show you what we're doing so we can, apologies, show you what we're creating. So it's one of those where you fill up the entire level with color, like that. And when you end, it says winner, winner, chicken dinner. So we have now completed the level and we've gotten the result of that. We can still continue playing, so because I haven't created a menu or like what to do. Now, mechanics you need to consider when I'm doing this is you can only go in one direction at any given point. Only when you collide with something are you able to choose a new direction. Yeah, so let's talk about that. So now that we know what we're doing, I'm going to move that off to the side and go to my clean project. Whoops, let's do this. Okay, I'm going to start by giving this ball a color that isn't bloody white. That's horrible. Let's do player. There we go. From my previous project. So you can choose any color you want. I just basically made this up of cubes, the Unity cube, and just color coded it. And all we did as a starting point is the ground is tagged as platform, and the colliders themselves are just standard. And the second thing that I think, I'm not sure if I've done yet, is I added a box collider. The mesh collider is for the floor, and a box collider. It doesn't have to be a mesh collider, to be honest. It can be another box collider. I've created another box collider, which I'm not happy with that height. So, and I just made it smaller so that you can't by mistake, if the box collider is the same size as the cube, the ball might go past it and select that cube, that color, and fill it in. So I just made it small enough to recognize that the player's passed through it. Made it into a prefab so that I can update all of them. Now all the colliders have been updated, which is what we want. So prefabs are very powerful that way, so please use that. There we go. So that's it. And on the player itself, I added a rigid body because I'm going to be using rb.movePosition to move the sphere. I tried a few different ways. I tried velocity. You got little issues like when I pushed right, it would kind of start to veer off path once it collided with the wall. So I needed something that gave me consistent results. So my first solution was to adjust the constraints. So when I moved in a direction, I would constrain the object. And then I found out that works really well in code, but in Bolt there used to be a way to access the constraints properly, but I haven't been able to set all of them. So I kind of had to rework my thinking to get the code to match both in Bolt and code. So this was my solution that I'm going to show you. So like I said, there's a rigid body on here, a normal standard sphere collider. So what we're going to do is start by adding a flow machine to our character. Create a new script. I'm going to put in my scripts folder. Again, don't name it this one because it makes absolutely no sense, but I'm just going to call this puzzle controller because that's what I've been naming all the others, so it's just going to be what I name. Okay, so that's what that looks like, and let me just look at my notes quickly to see what we're doing. Okay. We're going to start at the top. So first things first, I need to get a list of all the tiles in the scene so I can see, not a list, sorry. I need to just get the number of tiles in the scene so that I can, as I go over a tile, I'm going to subtract from that number so that we know when we've run out of tiles. So we can use a list, but I'm going to use an int. It's going to be a little bit, I guess, simpler. We have covered lists, so we don't have to cover that again. So the int is a little bit of a simpler process. So at the start, so let's move the update down. So at the start of here, we need to create a new variable. It's just going to be a graph variable, and we're going to call this number of tiles. And that's going to be an integer. I want it to be a whole number, and I'm going to grab that and I'll put it here. Now, what I'm about to show you is a really cool thing about Bolt, but you can't really do this in code. I've tried, but I can just go and say game object dot find and search for find objects, game objects with tag, but the plural version. So you'll see there's a little list icon on this side, and this is the part where I've tried in code, and we can try it again, but I wasn't able to get it right. I just drag off here and I type in count, So I don't have to do a for each. I just get the, straight away I get the count of items here. And I just pop that into there. So now we have the amount of items based on the tag. It was platform, all lowercase if I remember correctly, but just double check. Platform, that's it. So it's lowercase p. So, and this is all we need to do at the start. We're just getting the number of tiles, and we can test this straight away to see if it works. So get number of tiles in the scene at the start of the game. There we go. Be descriptive. I know sometimes if you guys are watching, you're like, that's a lot of like words, if you will. But if you come back to something a couple of months later, you're going to either hate yourself for not being descriptive, or and then you're going to be like, next time I should actually at least break down what I'm doing in each section. Because even when you look at your code a couple of months later, it might look a little bit foreign to you. It might, or worse, when someone else has to look at your code and then they don't have a clue what's happening, or they have to decipher your coding. So if you add like comments everywhere, it's going to be easier for them to track that. So let's see if that works. So I have my variable tab open here. I'm just going to go to my graph. I'm going to look at the number of tiles. It says 0. When I start the game, it should give us something like 49. I think that's how many tiles I've got in here. If I hadn't said maximize on play. Let's try that again. Please don't maximize on play. There we go, 49 tiles. So we now know how many tiles we need to get rid of or move through in order to win the game. So we have the first variable laid out and set up for us. Okay, so because we're doing Rigid Body, I'm going to be doing the actual movement in the fixed update, but in the update itself, this is where I'm going to be doing the actual input, so that it's a lot more responsive than putting it in the fixed update. So let's do the fixed update while we're here, and then we'll move on to the update, which is the biggest part. That's the actual input coming up, so going in there. So we're going to say fixed update, and in here we're just going to be doing a rigid body dot move position. And you're looking for position, not rotation. And if you're wondering why I'm not I'm I forgot my language right now. I'll probably remember it, so I'll come back to that. So again, we need to add something to this. So I'm going to need two variables for this. I'm going to expose the one. So I'm putting it in the objects. So I'm going to call this ball force. Let's call it ball speed. There we go. That's going to be a lot. It's not actually, it is force, but, and I'm going to set that to something like 10 as a default. We're going to drag that in because we're going to need that. And then we're going to go to the graph because I don't want this variable to be accessible to whoever's tweaking it, because this one is just going to be the direction of our input. But it's not our input. So this is going to be where it gets a little, stupid. Sorry, it needs to be a vector 3. What am I doing? Let's call this done. Sorry, I need to actually put in a name before I go crazy. Direction. Let's change this to a vector 3 because I need to know in what direction I'm moving. And because this is a 3D world, I need to consider that the Z will always kind of stay the same, but we need to know whether we're going, the Z will be up and down, X will be side to side, and Y will remain the same. If you're wondering how I know that, if I select my character, X is side to side, forward is up and down if you look in the game view. So let me move it across here. That's up and down, which is our Z, and X is our side to side, and then Y being up in the world is the value we're not concerned with. So before I forget, I just want to make sure that I lock. Actually, let's leave it unlocked and see what happens. I want to see if he just tries to escape the scene, if you will. Okay, so now that we have direction and we have ball speed, we're going to do something to add force to this object. So we are going to start by getting, when you're using a move position, it's the same as using a transform dot position. You need to first get the current rigid body dot position, and then you need to add to it that value. So we need to add to the current position, and then we're going to update the position that we have. So what are we adding to that? We're adding, hold on, let's move this down again a little bit more. This update's getting in the way. we're going to be updating a few things. First, we're going to get the direction, and we're going to multiply the direction, because the direction value is going to be a simple 0, 1, or -1. So it's going to be a normalized value. So we're going to be multiplying that. That's what we have the ball speed for. So we're going to multiply that value and plug it into B. So we're getting the direction in which we need to move. And then we're going to duplicate this multiply. Because remember, we're using velocity. So we're going to want to multiply that by time dot, in this case, because it's in the fixed update, fixed delta time. So that's it for the movement. This is going to be firing off every other frame, or depending on how you've set up your fixed update. So we get consistent, and again, multiplying by fixed delta time allows us to almost be, to some degree, getting frame independent issues. So if you don't have, like, if you get frame rate issues, this should kind of negate that. So let's call this movement, because that's exactly what it does. We are going to be doing, again, we're doing the input in the actual update. Just changing these colors just to make it easier to read. So now that we're done with this, we have to actually, this directional value has no input, so it's not going to go anywhere just yet. So if we press play now, nothing should happen because those values are 0. So if we start the game again, there we go. Nothing has happened. All that happened was the cube moved a little, the sphere moved a little bit above the ground, so it wasn't in the ground. And that's it. So let's get this thing moving, and that's where we're going to press the inputs inside of our update. Okay, so I want to keep track of everything based on a single value. So in my graph, I'm going to put an input variable, and it's going to be a vector too. You could make these into floats, call it like input horizontal float and then input vertical float. But I just want to have one variable to deal with as opposed to two. So I'm going to make this into a vector 2. So X is going to be my side-to-side movement, and Y is going to be my up and down movement. I'm just storing it that way. So we need to set those values, because we're going to be checking everything against these values. Okay, so how do we go about doing this? All I'm going to do is do a simple input dot get axis raw, because I only want a whole number from my inputs. I want it to be 0, 1, or -1. This one's going to be horizontal. I hope I'm spelling it right. I am not, obviously. There we go, that's better. And the horizontal value is going to go, we need to split this out so we can get a new vector 2. There we go. And we're going to plug this into X because it's our side to side, so it keeps track. And then the Y is where it gets a little confusing. I can understand that. Just think of the Y as your side, your up and down, which is, on screen it's right, but in the level it's Z, sorry. Okay, so now that we have this value, we're going to duplicate this and get the vertical. And again, if you're wondering where I'm getting these names, we're still using the old input system and not the current new input system that Unity has. I haven't found a really good way to kind of get them to communicate with bulk yet. So if we go to Edit, go to Project Settings, under the Input Manager, if you open that up, there's horizontal. That's what I'm calling. And what are the keys that are assigned to horizontal? It's the left and right arrow keys and A and D on your keyboard. And you also have another horizontal down here, which is going to be your left gamepad stick, X, which is side to side. And then you'll see we also have a vertical here, and that one is using the up and down arrow keys and the SW key. And as you probably have guessed, the other vertical down here is using the left analog stick up and down again. So in the y-axis. So we're just calling that. The reason I do this instead of get key code is it's like think of this as it's like marriage. You can't turn back. You're kind of stuck in that. So horizontal allows me to just call this, and I never have to approach the code again if I want to change my inputs. I just go to my input manager and change the keys that are assigned to horizontal or vertical. Okay, so I'm going to use what we call it's called a sequence node. It's a really nice thing in visual scripting that allows me to do multiple things in sequence. So this has a limit of 10. So if I try to put in 20, it only allows me to do a sequence of 10. So if you needed to do a few things, you'd probably have to double up on these sequences or do as many as you need. So for this case, I'm going to need to do 3. It just keeps things nice and neat. But remember, it does say the naming suggests that it is in a sequence. It's got an arrow, so it's going to start at the top and work its way down. The reason for that is first I want to raycast. Okay, so my x value I want to put a -1. If you're wondering why, I want my raycast when it starts to raycast in that direction, so it hits a wall. Because we're basing our movement on have we hit a wall before we can move again. So raycasting was the cleanest way to do this. There were a lot of other things like collision checks and all that stuff, and it got out of hand. So I thought the cleanest thing is just to do a simple, nice, elegant raycast. So now that's what we're going to do in the first one. We're going to do a physics.raycast. We're looking for origin, direction, max distance, the distance the raycast will go into the world, and the most important is what are we raycasting for? The layer mask. Okay. So origin is where is the object now? So we're going to just simply go transform dot position. So we're getting the position of our object. That is going to be the starting point of our raycast. Direction is going to be, again, it's pretty simple. We're going to actually raycast this in the direction of input or movement, which is our direction value. So as it stands, the raycast is going to start where the player is and move that way. And then when we push our buttons, it's going to go in the direction the character is moving. So it's always raycasting ahead of the character's movement. Now, that being said, we need to go to the object section and add a ray distance variable. And for this case, we don't care too much about like how far the raycast goes into. It just needs to go far enough for us to be able to hit the objects in the scene. So I don't think the camera is, I really think let's actually look at the scale of the character. The best way to judge this, the character is currently a scale of 0.95. We look at the sphere collider, the radius is 0.5. So the raycast needs to be a little bit bigger than 0.5, the distance. So I'm going to try out and just make it 0.55. So it's just going to raycast like 5 centimeters in real world scale outside of the character. We might want to make it a little bit bigger to give it a little more, allow it to be a little more responsive. So the bigger the raycast, you'll be able to change direction when you're close to the wall, but not on top of the wall. So play with this ray distance value to get the input that you're looking for. We're going to plug that into our max distance. Now the layer mask, I always like to create a variable for this that can be accessible outside of the code, because you can just simply go layer mask literal and then do it in here, but then you have to open up your flow graph to do that. So I prefer to create a variable. Let's call this a layer, and it's going to be a layer mask. That way we can, and then I don't have a layer just yet, so we have to go create one. So we're going to create one and assign it to all our blocking objects. So I'm going to go in my level, select all my blocking objects, double check that that's the case, yes. And in here I'm just going to choose a new layer. So I'm going to add a new layer, let's call it blockers. There we go. Whoops, spell it right. And then again, it doesn't automatically assign it, so you have to select all your blocks again and assign the blocker variable. And I'm also just going to apply the prefab. Just make sure that they're all assigned blocker. There we go. So now that they all have the right layer, I can just go into my object variables and select, let's try that again, blocker, and deselect that. Remember, you can multi-select inside of your layer mask, so make sure you're only selecting the one you want. Okay, so now that we have the start of the raycast, the direction of the raycast, the distance in which how far the raycast will go into the world before it dies, and then the layer that it's looking for, all we need to do is just do a little branch here for an if statement to decide whether or not we can move the character. That's all this raycast is done. Can we move the character because we've collided with something or the raycast has hit something. So based on that, we are going to simply create a new graph variable called canMove, I guess. It's going to be a boolean. Remember, boolean is just a true or false, yes or no. That's all we want to know. Is it true or is it false? Actually, I don't need this branch. What am I doing? We can just directly plug that into there, and this raycast will update this variable whether or not we can move based on the result of the raycast. So we're going to put a comment around this and call this raycast. Let's say if raycast is true, we can move. That is pretty much what that does. So if the raycast comes back as true, we can move. So that's all we're doing in here. So now the next two are just your horizontal and your vertical inputs. So we're just basically going to recreate the one, duplicate it, and change a few values. It is that simple. So the hard part is getting the one working, and then we can just repurpose the code and switch a couple of things around. So we're doing a branch here because we only want to be able to move if the following is true. So this is going to be a kind of a multi-layered if statement. So we obviously need to know, can we move? So if move is true, so we're going to do an and. So one of the parts is moving true, but it's not the only one. I don't want to be able to spam multiple buttons. I want to be able to say, if I'm pressing up, I shouldn't be able to go right, so I can't go diagonally. I need to go in a single direction only. So what are we going to do? We're going to grab, that's what we have our input for. So we're going to drag our input. That's why we've put it up in front of here. We're going to grab our input and we're going to say vector2.x. So we're getting our x direction because we're doing the side to side first. So we're saying, what is the x value? And we're going to say, as long as this value is not equal, make it a float, 0. So as long as, what that means is we're asking if we're pressing the button, essentially. We're saying if we're pressing the button, because then it won't be 0. And we have one more and check before we're done with this if statement. Let's just make this nice and neat so it reads a little bit better. Okay, so what is the next and? The next and is we're going to actually just copy just these two, duplicate those two. So as long as x is not equal to 0, but then y, so we're going to replace this with a vector2.y, needs to be 0. So if we're pressing the W key, then the A or D key has to be 0. Or in this case, if we're pressing the D or A key, it won't be 0. But then the other keys have to be 0 for this to work. If it's not, then we are pressing too many buttons at once, and we're going to get this weird result where we are we're going to be able to go diagonally or a weird direction. So we want to just say, this will only allow us to press one button or at least one directional value at a time, either horizontal or vertical. So back again to here. So are we pressing the A or D key? Are we if all the other buttons aren't being pressed? So if we're pressing the A or D key and we're not pressing the WS key, then we can go ahead. But if all of this is true, can we move? Is the raycast allowing us to move? So if all of this, we're just checking, we're going to put a comment around this if statement. If a single direction input is being pressed only and we can move. So that's what we're doing the checking. If a single direction input, wow, spell input right, please. If a single direction input is being pressed only, so only if we're pressing in a single direction, and we can move, then we're going to continue with the rest of this if statement. Again, whenever I have something in the update or the fixed update, I like to make sure that the only thing that's constantly being updated every frame is a single variable. Okay, along with the raycast, that too. So the single variable and the raycast. Everything else here will only happen if we if the values that we have are true. So it just keeps things nice and neat. It also doesn't allow us to like flood the performance of the PC to calculate all these bloody variables the whole time. Okay, so what are we doing here? Because remember, when we're doing the movement in our fixed update, all we're doing is making sure that we update the directional value with the correct amount. Okay, so let's do that. Let's make this character move. So now that we know we're updating the direction, so we're just going to drag in the direction. We only care about if this is true. The false, we are leaving blank. That's why nothing will happen when we're in the false. So that's how we manage our code and performance wise. So what is the direction? The direction is going to be, because we're moving side to side, I'm using a vector3.right. If you're wondering how to tell the right, forward, and up, let's talk about this. I'm going to select my character. Up, vector3.up will always be in the green arrow because it's moving up in the world. A vector3.right will always be the red arrow because it's moving side to side. And the vector3.forward will be the blue arrow, the one that moves in and out of 3D space. If you're doing 2D, it's a little bit different. You'll have a vector, the 2D, the vector3.right remains the same, but the vector3.up becomes your blue arrow because it's only got two axes. Because actually it still stays the same. You're just going to look at it this way. So side to side, and this is going to be your vector3.up. So just be aware you have no forward movement in your 2D games. And that's it. Major difference between a vector3.up and a transform.up is this. Let me do it with this cube. We rotate this cube by like a few degrees and turn this up at the top here to global. So vector3.up is using world up, world right, and world forward, like you see it over here. So it's straight up, straight to back and forward, and side to side. But if I change this to local, that is when we refer to a transform.up, transform.forward, and a transform.right. So notice how it's not really up anymore. It's kind of using the objects up and the objects forward and the object side. So that is how you decide whether or not you want to use which one. So that's why I'm using a vector3 dot so that I get the world right and the world up. Just hopefully that helps you guys understand that a little bit better. So we're going to get the vector3 dot right, yes, and multiply that value. The result is going to go straight into this variable, so we already know that. And what are we multiplying it by? By our input. So we're going to drag our input. Actually, I can just grab it from here because we're going to multiply it by our x value, because remember that's the direction that horizontal is. Plug that in. The reason I created a variable instead of just copying these nodes, you could have just copied these nodes, is just for cleanliness. It's just easier to track things once you've stored that into a variable. Okay, and that's going to make our character move, and only move if the raycast comes back as true. So I'm going to put a comment group around this entire section. We're going to call this one horizontal movement. Horizontal input, there you go, horizontal input. So that's what this does. It does our horizontal input. So let's test to see what that looks like and if that works. So I'm only going to be able to move side to side at this point. Let's put this into one screen. We don't need to see the other one. Okay, there we go. Notice our boolean down here that can move when true, but the moment I move, it goes false. When it gets within range of the wall, it goes. So if we make this value a little bit bigger, because we have the object, let's make it something like 1. Go back to our boolean. If you watch real close, it gets true a little bit sooner. So if I kind of spam it real close to the wall, I'm able to change direction. But if I spam it, that's actually really close. That's really big. That 1 is way too big. So notice how I'm able to kind of change direction just before we get the wall. So I think think 0.5 might have been a little bit tight, so I'm going to make it something like 0.6. Doesn't sound like a lot, but it is. These values can incrementally get quite big, so be very aware of that. I'm just going to test this one more time. So you can spam the button while moving right. Just try to go left and notice how it will only go. Oh, I tweaked the wrong value. Sorry about that. I tweaked the player's speed instead. Let's put that back to 10 and let's go to here. And sorry, I make that 1. And try that again. That was very weird. Let's try 1 more time just to make sure that I wasn't losing my mind. Yeah, 1 is still a little bit, so I'm going to go back to my initial 0.6 value. Make sure I'm actually using the correct raycast value. And then again, just move side to side and just spam it on the way to the right by pressing left. And notice how only when you get near the wall will it start moving in the opposite direction. So spam it all the way until you see when it actually does have an effect. So that is it. That's how we get our side-to-side movement. That is how we're getting our horizontal movement. So what do we do for our vertical? We just literally select all of the stuff, Control D to duplicate, move it down here, grab the sequence node 2, drag that into the second branch. So we have all of them connected together like this. I'm going to rename this one to vertical input. And now what do you do here to make sure that it works? You're going to reverse everything we've got in here. So wherever you see an X needs to be a Y, and wherever you see a Y needs to be an X. So I'm going to right click and replace this one with a vector2.y, which means this one needs to be an X. So vector2.x. So this section is done. We're just saying now look for the Y input is greater than, is not equal to 0, but the X input is equal to 0, and all of that's done. So now we need to just come here and change this input again, replace it with a vector2.y because it's currently an X, and this is the major change. We want to move the character in its forward. Remember we spoke about what the forward is? It is that axis. So I want to say, okay, I don't want to move right no longer. I want to go vector3.forward. And that's it. Now we have directional movement in all 4 directions. Remember, there is no diagonal input because this game shouldn't have that at all. So I'm going to put a comment around the beginning bit here saying store player input into a variable. That's all I'm doing in this section. I'm storing the player input into a variable. If I spelled store right. Store. Let's do that. Make it nice and okay. So store the player input into a variable. That's all we're doing here. There we were doing our raycast to see if we can move, and then these two are our actual movement. So let's test that out. I should be able to go up and down. While you're going up and down, you can check to see if you get performance issues. Again, don't have your flow graph open. It will affect your performance of your game. So just kind of have the console next to each other so you can hide it. Okay, so I can go up and down. So as I go side to side, notice how I try to push down, and it only goes down when I get close to the wall. There we go. So I can only spam the button in a single direction. The raycast might be a little bit, no, it's fine. We can probably shorten the raycast, but there we go. That's it. So now that we have the movement using a rigid body.move position, we can go in and do the actual change these blocks to be a specific color and subtract a value every time we go through it, so that we can check to see if we have won the game or not. The last thing I'll do is do a little we'll do a move count basically every time we overlap something. So we're just gonna, well, not every time we overlap something, every time we press a button, we're gonna track how many moves it took us to complete this. So we can maybe create some sort of star system in the next video where we can say, let's say as the game developer, you're able to finish this level in 10 moves, and the player gets there in 10 or 9 less moves. So they get 3 stars. If they get somewhere between 10 and 20, they get 2 stars. and 20 and up, they just get a single star just to show that they finished the level. So we can do some sort of star system for this. So now that that is working, all we need to do, for those of you who kind of are new to Unity and you kind of, I don't know if you've already found yourself working in play mode, what I find a good habit to have is just to go to my preferences, just go to my general, no, where is it? Sorry, colors, there we go. And you'll see that there is a play mode color. So let me just find it. Animation, sorry, play mode tint, there we go. So we can just make this a different color just a little bit so you can see when you're in play mode, so that you don't, it's a visual reminder. There we go, now it's kind of blue. It's a visual reminder that you are currently in play mode. Please don't adjust anything. It doesn't seem to work with the flow graph, which is nice. You can actually do stuff at runtime and it will remember it, but not everything else is like that. The rest of it kind of breaks. So just be aware that what you do while you're in play mode will get undone, or it won't be saved or remembered. So now all we have left to do to make this game complete, sorry, is do an on trigger enter. So on trigger enter. Again, if you're doing a 2D game, same thing. Everything where I have a 3D rigid body, do a 2D one. Wherever you have an on trigger enter, do an on trigger enter 2D, like there. So when we enter this trigger, I want to make sure that I'm entering a, remember we called it a platform, I think it was. Yes, platform. That's how we search for them in the beginning at the top here. There, let's keep going. There. So we are aware of those platforms. So we just need to, at the bottom here, I want to make sure that I am actually hitting that platform. So I'm going to do a compare tag. Plug those two together like that, and let's just plug this directly into a branch. Remember, yes or no. So yes, I found that platform, or no, I didn't. So bool is probably the easiest variable to keep track of. It's also one of the most powerful, because if statements, case statements, all of these are really powerful if you understand how you can just get a yes or no. So that is how if statements work, and that's how we use booleans for those. Okay, so we only care about if it's true. If it's true, I'm going to grab my tiles, number of tiles, and like we did in the beginning where we got the amount of tiles, we're going to do the opposite. So we're going to grab the tiles again. One is a set and one is a get variable. So first we're going to get the current amount of tiles. We're going to subtract the amount. So, wow, my English. Ooh, subtract. So I'm going to subtract a value from this. And in this case, I just want to subtract a single value, 1. Now in code, you do a plus plus or a minus minus. If anyone in the comments knows how to do that in Bolt, without having to do what I'm doing here, I'm just taking a single value, subtracting 1 from it, and then I'm telling the current number of tiles, you are now less 1 tile. So this is all we're doing is just, again, let's put comments around each section of the code to make sense of it. So over here, all we're doing is subtracting 1 from the tile count when we enter the trigger. So that's what we're doing. Every time we enter this trigger, and now the emphasis is on every time. So we now need to be aware of it. If we cross this tile again, we're going to keep subtracting, so we're going to end up in negative values. So we don't want that. So after we've done this, we are going to disable, if we go back to the level, we want to disable this box collider. Not all of the colliders, just the one that we're using for a trigger. That's why it's tagged as trigger. We want to, once we go through it, we want to turn it off so that we don't get an on trigger with that cube anymore, so we can't keep subtracting every time we go through it. So that's all we want to do there. So how do we go about that? We are going to right click and type in box collider, because that's what it is, .enabled. And we want to set the box collider.enable to false. But where is this box collider? We could just simply do it on this object, but the player doesn't have a box collider. So where is that box collider? It is currently on the object that we collided with. So we're going to go game object dot get component. So we're getting the component. What component are we getting? We're getting the box collider. And then we're just going to plug that directly into there. So we're saying find the box collider and turn the box collider off. So let's see if that works. We're going to select this last one here, and we're going to keep an eye on the box collider. When the character gets in there, it should turn itself off. So while we're running the game, we're going to be looking at this box collider here, and we should see this little tick box turn itself off. There we go. And if we look at all the box colliders between where the character was and where it moved, they should all be disabled. So we now know that we can't get... Oh, we didn't even check to see if the value was right. So we're going to check to see if our number of tiles decreased as well. It's down here. Number of tiles. Number of tiles is 48 because we are already currently in the starting tile. As we go across, we've already removed the tiles from that value. As we go down, we keep removing them. Notice how they're all being removed. So that's a good sign. So a lot of the work has been done. So the next step is we need a object variable, and we're going to add a color. Let's call this overlapping color. So this is the color we're going to change to once we have overlapped. You could do a material change if you want. I'm just doing a simple color change. So type in color for the variable, and I think we're just going to make this, what is the kind? I'm going to make it the kind of the color of the player, so I'm just going to make it a blue, so that it looks like the player is leaking into the world. This game is based on a mobile game that I saw in the same vein. There's so many of them, it's hard to keep track of which one I actually saw originally, so I'm not going to even try to remember it. Okay, so the next step is to do a type in material.color, and we're looking for material.color set. We want to set the color of the material, and what do we want to set it to? This color. Again, we leave it the way it is. I'll plug it into, now plug it into the right one. Problem we're going to have here is we're going to set the player's color. So let's try this. Oh, actually the player's color is already blue. So let's just change this color to something like a pink. So we have to, again, what do we want to change? We want to change the tile, not the player. So when we start the game, we move. Actually, we're not even changing the player's color. Oh, because we're not getting the color. So that's already a good sign. I didn't even have to show you what goes wrong. It already goes wrong from the start. This is good. Okay, so what do we want to change the color of? We're going to duplicate this node, and we're going to say this object we collided with, get the mesh renderer, and from that get the material Actually, I wonder if we can just, no, we can't. Actually, we have to type in, my apologies, renderer.material. We need to get the renderer material. So the material that's assigned to this renderer, if you have multiple materials, it's going to find the first material that you have. So if you have like 20 materials, you're going to have to cycle through all of those materials and change them. Just be aware of that. So I'm just going to put a comment group around this. Get components in the current overlapped object. There we go. Let's call it tile. So get the components in the current overlap tile. That's all we're doing here, and we're setting it there. So now what we're doing, and why the reason I use the mesh renderer, if we look at this box collider, for example, this platform, you'll see that you see the material here, but the only thing you can access in this is the color, and you can't actually, there's no component called material. So if you look at the mesh renderer, if I turn that on and off, that is what renders the object to the view. So if I open up the mesh renderer, you'll see that there are multiple tabs: lighting, probes. So lighting, whether or not it receives shadows or can cast shadows, light probes using light probes, and additional settings for motion vectors, so, and for dynamic occlusion. So what we want to do is go under the material section. You'll notice there is a list. So I could have multiple materials in here, which I don't, but I could. And when the way we've searched here, we're saying find the first material. And so it's saying find the mesh renderer, find the materials, and then set the material color of this material, which is called green, to whatever color we want it to be. So that's all we're doing in that code. Same thing with the box collider. We're saying find the box collider and turn it on and off. That's all we're doing there. So now if we go through the level, we should be able to kind of gauge whether or not we're doing well. Colors will change, and then we'll see the number of tiles go down. So there we go. There we go. So I'm going to play this level. I suck at my own games. This level is based on a design from the existing game. And now we have one more tile left. We have one more tile left. So if I go over that, I should win. Success. You have made it. So we need to have a check after this. So after all of this stuff, we are going to drag off the end here. We're going to do a branch because we need to do an if statement. And this is going to be a very simple if statement. We're going to grab the number of tiles. And we're going to see if the number of tiles is, I always do a less or equals to or greater or equals to. That's because in the past I've always used floats, and floating points, if you've noticed, don't always round up properly. So if you say the number of tiles has to equal 0, or for example, if you tell your player health needs to equal 0, and your player health when you're using a float might be 0.001, code is extremely unforgiving. Then your player will never die because it didn't reach 0. So that's why I do a less or equal to, because if at any point this value is not exactly equal to 0, but it might have gone a little under, then I still want it to be game over. You have won. Success. So we're going to put in a debug log in here. So type in log, look for debug log message. And I'm going to drag off the message side here, just add a string, because remember debug logs can put in variables, so you can plug a variable directly into there. But I'm going to just put in here winner chicken dinner. So it's just going to debug this to the console called winner chicken dinner when this happens. So I'm going to put a comment group again around here. Actually put it around the entire piece of code here. And we're going to put a comment around this called, wow, that's a really bad placed comment. What happens when you win? Or finish level, actually. Finish the level. Okay, so this is a question. I'm putting it there so you can decide what happens when you finish the level. It's up to you. I don't want to tell you how to make your games or what should be in there and what level design, all that sort of stuff. So you need to kind of decide what you want to do when you, what happens when you finish the level. So we're just going to debug something here, but we are going to be able to do one more thing, and then we're complete with this entire system. So I'm going to go to my console to see what happens when we win. It should debug winner chicken dinner. So let's just go through and get this going. Again, I think it's just, my brain says this is the quickest route, but there's probably no. There we go. Winner chicken dinner. That's it. So I just want to do one extra step for later on whenever you want to kind of compare how the player is done. So let's just put all of this, move it down a little bit, and let's add one big comment group around this entire thing. Call this on trigger enter. So we can keep track of what happens when you trigger go through the trigger, so that this is all the trigger related code. So we can just simply just make this nice and neat and move this over here. So we're going to do a custom event. So every time we click a button, we're going to add one to our movement count, if you will. So in the graph here, we're going to create a, let's say moves taken. The amount of moves that it's taken to do this. So it's going to be an integer because I want a whole number. We're going to drag this in. Now we're going to do the usual. We have to drag in a get, and we're just going to add 1 to the value. So every time I press a button, I want to add 1 and update that. So over here, we're just going to do a int literal and just put 1 in here. So every time I click a key, I want to add 1 to the movement count. So we're going to use a custom event to keep this nice and neat so we don't have this code all over the place. So a custom event, let's call this update input count, I guess. I'm not going to have any spaces. That's not update input count. I'm going to select that and Control C to remember the name. I don't want to kind of keep track of it. Just put this nice and again neat. Just try to kind of make your code as neat as possible so that it makes sense when you're looking at that. Goes for both C# and visual scripting. Let's say update every time the player moves. Actually, that makes no sense. Add 1 to the movement count every time the player moves. That makes a little more sense. So add 1 to the movement count every time the player moves. So how do we call this function? Because remember, it's not being called, and it is green, which means you can fire this and be called from somewhere else. So we're going to just put this at the bottom here, and gosh, I really should make that text. I know it makes it bigger for readability, but it makes it difficult to select things. So we're going to go to our input. It's going to happen here. So after we've done all of our input, we're just going to drag out of here and say trigger custom event. I'm going to paste the name that I created called update input count, plug both input values into that, and I'm just going to say, we're going to say call input count, just so that we know what we're doing there. If like later on you're like, what the hell was I thinking when I did this? So here we're calling the input count. And that's it for this tutorial. We will test it by looking at our moves taken and see every time I click the button we should be adding, let me just make this a little bit bigger, 1 to that count. That way at the end of the level we can see how many moves it took us to complete it. So let's see how many moves it takes. That's 1 move, 2, 3, 4, 5, 6, 7. This is definitely not the most efficient way. Okay, that's 27 moves. So you can keep track of that, and then you can store that value into compare that value to what is a good amount of moves versus what's a bad amount of moves, and do something based on that. So I'm going to see if I can do it in the less moves this time. That was definitely by 3, I think it was. So there we go. So we have a move count, and then again, you can, when you have successfully, what happens when you finish the level, you can check your moves taken to a certain amount of moves and do the appropriate. So if we were to grab this just as an example and say, I really like this comparison node, so I'm going to use it. So here's my comparison node, and I can compare it to a certain amount of values. So if you've done it, if it's greater than that value, then you get 3 stars. If it's less than that value, you get 1 star. So you can say that 2 stars is, let's say 20 is 2 stars. There we go. And you can do something here. So you can say, let's just put this debug after this. We're going to compare something now. Now we're going to do things here. So we're going to put a branch again, because remember this is pink, so which means we need a branch. So we need to know what happens if it is equal to. So equal to means we get 2 stars. So we're going to do a branch. And we're going to do a sequence node here. Now this is off the cuff. I'm kind of just doing things. So we need 3 values. So 1 for 1 star. We're going to do the next one here. Again, sequence nodes, doing it in order. In this case, it really doesn't make much of a difference. It's just going to compare them one after the other. And we're going to just use this debug log. We're going to duplicate this here and duplicate this there. And we're going to say if the value is less than, it's going to be 1 star. If the value is greater than, it's going to be 3 star. Sorry, the other way around. My bad. Yeah, so yeah, that's going to be, if it's less than, it's going to be 3 stars, 2 stars, 1 star. There we go. That makes a little more sense. So if we're doing less or more moves. So if you're using less moves, you're going to get 3 stars. So let's call this 3 stars. I mean, that's going to be my extent of what the amount of code we can tackle UI at a later stage. So if it's 3 stars, we're going to do that. Duplicate this one. This is going to be 2 stars. Again, so you choose what that value is based on, I guess, how many people play it, get the average, and then kind of from play testing, and then decide where the middle ground is for 2 stars. And then like for your really exceptional players, you're probably going to want to use whoever the best player is in your devs team, their result, and use that probably as your 3 stars. Just don't make it too easy to get 3 stars, but again, it's up to you. So I'm just going to put all of this code in a section called example code. Let's put this as an example result. There we go. This is an example of what you can do with what we've done. So I feel that stars, you could also just directly compare moves, like how it took you 20 moves the last time, but it took you 2 less moves this time. So let's see what happens. It should print out to the console. Instead of saying winner, winner, chicken dinner, it should tell me whether I got 3 stars, 2 stars, or 1 star based on that 20. So I don't think I'll ever get below 20. So I think I'm going to get, you'll see now. There we go. I got 1 star because if we go back to our code, if it is less than 20, it'll give us 3 stars. If it's equal to 20, I get 2 stars. But because I didn't get to 20, I am getting 1 star. So I'm going to try to give myself, let's give myself some grace period here. I'm going to make this 30 because then I will be able to get 3 stars. So just to show you that the logic here works. So we're going to do a check here. You could also use a switch statement for this, so you can check to see, but I find that this is a little bit more a lot of developers are on the fence about switch statements, and some are for it, some are against it. So I just, in this case, I prefer to kind of, okay, sure, I should get 1 star again. My ass. Oh, I did 39 moves. Hold the phone. Why did I have 39 moves? That's crazy. Let's double check that move count. Something is weird. It's happening in that move count. I'm not happy with that move count. I feel I'm being cheated by my own game. Let's see. Move count is currently... I can actually see the bloody variable. Why can't I see my graph? Anywho, let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Okay, so I'm going to pause it so I can see what the hell is happening. I'm getting 39 moves taken. That is complete and utter rubbish. That is complete BS. So I'm going to print out if you're like having issues like I am, I'll double check why my move count, earlier on the move count was perfect. So maybe I've broke my logic. Number of tiles. Here we go. We're subtracting I'm doing the wrong thing. No, that's right. Moves taken, subtract, add 1. We're doing it in here. Every time we take a move, we do want to update the move count. Go down here and add it. So I'm going to do a debug log here. Every time I want to log out what that count is. So it's good that this is happening, so you can kind of see how you're going to use a variable and plug it directly into a debug log. Especially if you're using an event like a graph variable where we can't actually see it. I'm going to double check what is happening here. So we should have, when I tap the button the first time, we should have 1, 2, 3. Oh, that third one gave me 3, 4, 5. Yeah, we're getting multiple hits at this point. That is very interesting. So for some reason, I think based on my input logic here, let's just double check that that is right. We're getting a few fires here, but we are using get access raw, that is correct. So we shouldn't be getting weird multiple hits. So I'm going to just, again, put in another failsafe here. Again, be very vigilant about making sure that you do you do things that are not that are solid and they're robust. So we are going to only update this. No, but we're doing it there. We don't need this here. So let me go and take a look at my code. It is the first time it's fine, but after that it just kind of exponentially keeps adding 1 here every like 3 times actually. That's why we got so many big values. We were getting some ridiculous values. Can we not fight with me right now? There we go. Let's see. This has to be equal to 0. Correct. That has to be greater or than, basically not equal to. Updating the input count, that is correct. So what exactly is happening here? That's interesting. I want to try something. Again, this is up to you if you want to do this part. I'm going to remove this piece of code here. Just break it, delete it just to test on the one direction. And I'm going to go input.get mouse button down. Not mouse button, sorry, input.get button down. I'm going to copy the horizontal from here. I think it might be the fact that I'm getting a variable that might have a variable output. It is possible that that could be what's causing this inconsistency. So let's see if putting horizontal in there should rectify the problem. We can straight away see the debug log here. Okay, that seems to give us a little more consistent results. Let's try to do the same. We'll do the exact same thing down here. It's not a big code change. We're just removing that section there, and we're just getting a if the button is down instead of if the movement is not equal to 0, essentially. So we're now being even more stringent about what happens. I honestly thought that the other one would be fine, but apparently it's not. So let's just see if we get the correct values this time so I can get my stars that I want. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There we go. Okay, so that worked that time. So if you're wondering what we changed, all we did was over here at this point here, we are just being a little bit more strict about saying, okay, instead of whether the input is like at this point here, we said, is the input not equal to 0? Because apparently this get access raw is giving me some in-between values, or it's still taking looping. It should be a straight 0, 1, or -1. That should have worked. We're just saying only when the button is down, both on that case and this one here. So we're just making 100% sure that we are saying only if the button is down for vertical and horizontal. Okay, so that's it. Thank you for watching. That last tweak is actually quite helpful. It does give me the result that I want. Until we see each other next time, be safe and good luck.